In the last video, we talked about the slope of a line segment, and now it really is time to talk about the slope of a line. So before we can talk about the slope of a line, we need this fact. So this is a theorem. And the theorem says this. Let's say that you have a line, which I'll just make going up. The theorem says that all line segments on a non-vertical line. Now, why do we need a non-vertical line? Because vertical lines don't have slope. Right? Vertical line segments don't have a defined slope. So all line segments on a non-vertical line have the same slope. Now, if you think about the steepness, it kind of makes sense that this is true. I mean, intuitively, because the slope is a measure of the steepness. And if you look at this line, it's not like getting more steep as you go to the right. Like, it's not like, you start at this steepness and then change to that steepness and then go down to this steepness, like negative slope, and then changing the steepness and changing this, getting steeper and steeper and steeper. It's not doing any of that, right? A line is just the same steepness the whole way. So it makes sense that intuitively you should get that whenever you have two line segments, they have the same slope. So let's say, to see what's going on, let's say that I have these 4 points. Let's call this point A. And let's call this point B. Okay, so that's a line segment, the line segment AB, which is the same as the line segment BA, right? This line segment. Or suppose that I have a different line segment. Let's say this point C all the way to this point D. Okay. Now the line segments don't have to be the same length, right? Slope is not about length. Slope is about steepness. And why do these two line segments, A, B, and C, D, have the same slope? Well, let's draw some triangles. So I'm going to fill in this line to make triangles by dropping parallel lines from B and D. Okay, they don't have to go, okay, I'll just make them go all the way down. And then I'll draw horizontal lines through C and A, like this. Well, when I do that, I end up getting right triangles here and here. So let's call this point where this point M, and then let's call this point N. So now I have triangles, I have right triangles triangle AMB and triangle CND. Now the key fact is that these right triangles are similar. Now how do we know that they are similar? Similar meaning, well, there's lots of different ways of thinking about similar triangles, but one way I think about it is that the angles are all the same. So why is that true? Well, they both are right triangles, that's one angle. And for the other one, we have to recall this fact that whenever you have two parallel lines, and I have two parallel lines here, I also have two parallel horizontal lines, like this. When you have, let's look at the horizontal lines. When you have horizontal lines like this, and a line that goes through them, there's the fact that the angles that the purple line in this case, makes with the two parallel lines are the same. In other words, this angle here is the same as this angle here. These two angles are the same. Well, in terms of this picture, I have these two parallel lines. Let's call this parallel line L1, L2, and then this purple line Okay, it's the one that goes through. I'm applying this fact to this line L1 and this line L2, and the line that goes through those parallel lines is the line that I'm trying to find the slope, that I'm trying to say something about the slope. Okay. So if you look at the picture, what's going on is that these two angles are the same. Well, if those two angles are the same, okay, and I have right triangles, then what does that tell you about the triangles? They have to be similar, because what's going on is this third angle, remember all angles of a triangle add up to 180 degrees, and so the remaining angle must be the same. Okay. In general, whenever you have two triangles and two of the angles are the same, then the other one has to be the same. Like the other pair of angles has to be the same. So I have similar triangles A and B and C and D. So in other words, if I make this green, this whole thing green, this green triangle and the blue triangle are similar. And what can you say about the ratios of corresponding side lengths when I have two similar triangles? They're the same. So if I look at this blue triangle and look at DN over CN, that's the same as BM over AM. Well, what's DN over CN? That is the slope of the line segment CD. And what's BM over AM? That is the slope of the line segment AB. Therefore, these two slopes are the same. And that is the reason why two line segments have the same slope. As this is actually only when the slope is positive. Okay. Well, first of all, if we have a horizontal line segment, if we have a horizontal line, then any two of the line segments will be horizontal, and then the slope will be 0. So they're the same. What happens if you have a slope that is negative? So in other words, if you have a line that's going down as you go to the right. Well, in this case, okay, again, let's have our 4 points, A, B, so that's the first line segment, and then the second line segment, C, D. And again, we're going to fill in our triangles like this. And let's call this point M and that point N. So I have right angles. And again, these are similar triangles for the same reason, because that angle is the same as that angle. And I have two right triangles, and so the remaining angles must also be the same. That angle is the same as that angle. So similar triangles, and therefore, by similar triangles, I see that AM over MB must be equal to CN over ND. So triangle AMB is similar to triangle CND. That implies that AM over MB is equal to CN over ND. And remember, what did we say about AM over MB? That's the ratio of the side lengths. How is that related to the slope of AB? It's negative, right? That is negative the slope of AB. And CN over ND is negative the slope of CD. So negative 1 times the slope of AB is negative 1 times the slope of CD. And of course that tells you that the slope of AB is equal to the slope of CD. So even when the line is sloping down, it is still true that the slope of any two line segments on the line are the same. Now with this fact available, that any two line segments on the line have the same slope, we are ready to define the slope of a line. The slope of a line, before we've just talked about the slope of a line segment, now we're ready to talk about the slope of a line. The slope of a line is the slope of any line segment on the line. In other words, let's say you have a line like that, and it just goes out, it's going out forever. Then the slope is what you get whenever you take any two points. Okay, once you take 2 points, you get this line segment. You find the slope of that line segment. That's the slope of the line by definition. So let's call this line L, and let's call this line segment AB. Okay. So in other words, the slope of L, this line, is defined to be the slope of AB, where A and B are any points on the line, not the line segment AB. And remember, it doesn't matter. So lots of things don't matter. It doesn't matter. Once you pick 2 points on the line, it doesn't matter which one you call x1, y1, and which one you call x2, y2. Okay, you get the same thing. And it doesn't even matter which 2 points you pick to get the slope, because if you pick 2 points and get the line segment and then find the slope of that line segment, and your friend finds the slope of a different line segment, the theorem that what does this theorem say? You're going to get the same number. So that's why there's no issue with saying the slope of a line. Like, it would be bad if the slope depended on which line segment you picked, right? I mean, I'm saying to get the slope of a line, right, what it means is pick any line segment, take the slope. And you might say, well, which line segment do you pick? And the theorem says that you can pick any line segment. It doesn't actually matter. Okay, so the slope of a line is a number. So every non-vertical line has a number assigned to it, the slope. Right? This number is a measure of the steepness of the line. A vertical line has undefined slope. Horizontal line has a slope of 0. When the line is rising from left to right, the slope is positive. Actually gets more and more positive as the line gets steeper. As if you have a line that goes down as you go to the right, then it has a negative slope, and it gets more and more negative as the line gets more and more steep in the negative direction. Okay, and what was the key fact about the theorem, the proof? It was the similar triangles. Right? It was the similar triangles that gave us this ratio equaling the other ratio. The ratios of the legs of the triangles. Okay, that's all I want to say in this video.